Well, this is John Black, Super Chemist. This is going to be a fast video. I'm putting sodium into ether, diethyl ether, to get the last traces of bit of water out of there. It's a very dangerous thing to do. If you have too much water in there, it will create hydrogen, and the hydrogen will ignite because it's really exothermic. And if that ignites, obviously the ether is going to ignite. You're going to have a fireball on your hands, and maybe even a fire. You might catch yourself on fire. This is what I'm showing you here. This is what you should actually be wearing to do this. I know it sounds crazy, but I got the fire coat, like for a fireman. I got the gloves, right? I got the mask up here. You know, it has the plastic, whatever. That's what you should be wearing, all right? So we're going to go. I don't really have volume in the fume hood. So what I'm going to do is, when I get over there, I'm going to just pop the sodium into the diethyl ether. I'm going to have a little bit in there. If it doesn't blow up or anything, I'm going to put the rest of the diethyl ether in there. I want you to notice when I put the stuff in there, nothing really happened. You couldn't really see it on camera because it was so cloudy. The molecular sieves, you know, they get like dust on them, and the dust gets in there. You know what I'm saying? But I could see, and let me tell you, there was not one bubble. I didn't see one bubble made. I mean, that stuff must be it must have been, that was a waste of time, really. There was not one bubble. So I'm going to just distill it, right? And then I'll be ready. That's it. I'm done. I'm going to do a grignard. Now, if it would have bubbled, I would have waited for it to be done bubbling. Maybe even, you know, put a stir bar on it and stir it for a while. Being that it's bone dry, I'm just going to basically heat up my distillation in the oven. Make sure there's no water, you know, adhered to the glass, and then I'll distill it. The next time, I probably won't even do this with the sodium, being that I see how, I mean, there's literally no water in there. I mean, it's bubble free. Now, someone told me that you might have some sodium peroxide in that aggregate, because I didn't use real sodium. That's just sodium aggregate from, you know, the thermal reaction where you do the sodium hydroxide and the magnesium metal. Um, so as long as you keep oxygen out of that reaction, you shouldn't make any peroxides. But obviously, you're gonna, you're gonna have some oxygen. So you might make a little bit of peroxide. I don't know. It depends on how you do your reaction, I guess. If you keep the air out, the oxygen out, so it does produce a lot of smoke when you do that, a lot of pressure. So that pushes all the oxygen out of the, the reaction vessel. So peroxides, I don't know, but it is something to think about. I would have never thought about it. That's how you make sodium peroxide. You got, well, actually, I don't know how you make sodium peroxide, but I'm guessing that you heat up some sodium and bubble some oxygen through it. And that's basically, you got a lot of heat with this thermal uh, reaction, with the sodium hydroxide and the magnesium. You might say that this is just aggregate. Maybe there's not that much sodium in there. So we're going to put it in some water and see what it does. You notice how at the end there, how it all turned white? It's from making sodium hydroxide. Sodium and water makes sodium hydroxide and hydrogen. Anyways, y'all have a great day, and always remember, science is great.